Hello, today we're going to do Module 4, Lesson 2. And today we're going to decompose and recompose shapes to compare areas. So decompose means to take apart. Recompose means put them back together. Compose means put it together. So we're going to take things apart and then we're going to put them back together. And in our lesson, we are going to be doing that with a piece of paper, a strip of paper. We're going to cut it up and put it into different shapes. But our work today is not quite like that. It's similar, but not quite. Okay, so let's start with an application problem. Now this one's going to take a little bit of drawing. I'm going to do the best that I can. 1, 2, 3, 4. Okay, I have to draw two shapes. Now this is, Wilma has a shape that looks like this. 2, 3, 4, 5, 6. Okay, and then see if I can figure out how to draw this. This goes here. This goes here. This goes here. See if you can draw that. See how I'm drawing a triangle and I'm cutting it in the middle. I want you to try it. Try that. And then I'm going to come over here and in the middle I'm going to cut the shape. Oh, lost my pencil. Where's my pencil? Here we go. Right down the middle. And do you see what that leaves me? Do you see what that leaves me? It leaves me with parallelograms here, a triangle here, and then a 1, 2, 3, 4, 5, 6, a hexagon here, right? Okay. This is Wilma's shape. Now this is Freddie's shape. Now let me see if we can draw Freddie's shape. His is a great big long trapezoid. So when I make a trapezoid, I make two parallel lines and then I make one line longer than the other. Okay? Now this one, see if I can do that. There's a triangle here and a triangle here. Okay? And then, see if I can do this. This is very tricky to draw this. No, and I've lost my, okay, so this goes here, this goes here, this goes here, and this goes here. This one goes there. Parallelograms down there. Okay, and a parallelogram here. Parallelogram there. Okay, now inside my triangles, I actually have a parallelogram here, one here, parallelogram here, one here. Now, if you were not able to draw this, that's okay. Just do your best, and then, so I have a record that you even tried it, and then look up here on mine. Okay. Now remember, these are pattern blocks. So my hexagons are yellow, the parallelograms are blue, the triangles are green. Okay? Now that we have our pictures drawn, let's read our question. Wilma and Freddie use pattern blocks to make the shape shown. Freddie says his shape is bigger than Wilma's because it is longer than hers. Is he right? Now, when he's talking about bigger, he wants to know the area. Okay? Now, we've got different shapes. So we can't say it has an area of 15 squares because they're not all squares. So we have to count each shape to figure out how much there is. So let's count Wilma's. Whoops. Let's count Wilma's here. Find my pencil. Come on, come back. All right, let's count our parallelograms. 1, 2, 3, 4, 5, 6. So 6 parallelograms. I'm just going to draw this way. Okay. How many triangles? 1, 2, 3, 4, 5, 6. 6 triangles and 1 hexagon. So I make it like this, and then I put the sides, and then go over. Okay, so 6 hexagons. This is her area. Now let's count Freddie's. Let's see how many parallelograms there are. So, because I know I'm counting parallelograms, doing that way. Okay, let's count. 1, 2, 3, 4, 5, 6. He's got 6 parallelograms. How many triangles? 1, 2, 3, 4, 5, 6. That's 6 triangles. And 1 hexagon here in the middle. Now, how do our numbers compare? Well, Wilma has 6 parallelograms, so does Freddie. She's got 6 triangles, so does Freddie. She's got 1 hexagon, so does Freddie. So, is Freddie's bigger? No. No, he's wrong, isn't he? They have the same area. Just because it's a different shape it does not mean that it's got a different area. It still has the same shapes. So Wilma could make Freddie's with all the shapes that she has, and Freddie could make Wilma's with all the shapes she has. Okay, so now it says to explain. When it asks you to explain, it wants it in words. Okay, so first we need to say what, because it asks if he's right. We need to first say if he's right or wrong. We know he's wrong, so I'm going to write Freddie is incorrect. Incorrect is just a nicer way of saying wrong. Because if it was your name here and we wrote your name is wrong, you could be offended. So let's be polite here. So Freddie is incorrect. Let's say his shape. His shape has the same area as Wilma's. So so his is not bigger. So his cannot be bigger. Okay? All right, here we go. Period. Don't forget your capitals. Don't forget your periods. Otherwise, it's not a sentence. Right? Okay. So just because it's a different shape and it appears longer, if it uses the same number of units, then it has the same area. If it has the same area, it would be considered the same size, right? Okay. Now, let's move on just a short little bit. When we did what we're going to be doing in class today, or the next day, after you see me again, so I'm going to give you a piece of paper, and it's going to look like this, and you're going to have lines drawn on it. Okay? Then we're going to cut them apart. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? You're going to have 12 pieces. Now, what would the area of this rectangle be? This area is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this area is 12 squares, right? Okay, but what if I take it and I cut it apart and I lay it out on my table, and now I make it like this? Whoops, I needed some more. 1, 2, 3, 4. What if I make it like this? What's my area? 1, 2, 3, 4. Oh, 2 across. How many down? 1, 2, 3, 4, 5, 6. 2 times 6. Fast way to do it is 12. So my area is still 12 squares. Okay, so remember I cut them all into one. Each one of these is a loose piece now. Okay, so what if I do this? And I make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What if I make this shape? What's my area of this shape? Well, how many is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My area is still 12 squares. Okay? So, when you see your homework, you're going to be given different shapes, and you need to figure out the units of their areas to see if they are the same. Now, how come this shape, which is a lot shorter than this shape, has the same area? It has the same area because it has the same number of pieces or same number of squares inside it, right? So don't get tricked just by the way things look. You need to take the time to do your counting. All right, good luck. I'll see you later.